Hello, my dear student. Hi, I am Vipin Mishra and I welcome you all on the IMS GATE Academy. I hope you all are preparing well for the GATE exam, and in the meanwhile, you are enjoying our GATE Booster series as well. So in this series, today and tomorrow I am going to discuss a very crucial subject and a very important subject as per the weightage of this subject is concerned, and that subject is none other than the subject power system, a very important subject. So before actually discussing the question, let me reveal you the fact. I have designed the question and I have chosen the concepts from where you can really expect a question in this year GATE exam. So I have done a lot of research. I have gone through the last 15 years papers and then I have designed the questions. So whatever questions I am going to discuss here, you can expect the same question or the similar kind of conceptual question or the same concept being repeated in the upcoming GATE exam. So these sessions are going to be a very useful one for you. Okay. Last session that I have taken on power electronics, there you people have enjoyed a lot because we have discussed some very important questions, some very good questions. The feedback that I have received from you guys was excellent. So the same kind of experience I am ready to give you in this session as well. So let's get started. Hello, good evening, Naman. So before actually starting, let me tell you, in this subject power system, I have divided the topics into following 7 categories. The first one is the compensation technique, the second one is the load flow analysis, and the third one is insulator cable and distribution. Fourth one is fault analysis, fifth one is power system stability, sixth one is performance parameters of line, and the last one is power system protection. So these are the topics that we have to discuss here, and the overall weightage of this subject is around 11 to 13. So a very crucial and a very important subject as far as the GATE exam is concerned. So we have 2 sessions today and tomorrow. So today I will be covering the compensation techniques, load flow analysis, and insulator cables and distribution, and tomorrow I will be covering fault analysis, power system stability, and the last 2 topics. Good evening, Naru. How are you? So did you people enjoy the power electronic sessions? The same kind of experience you will be having after joining these sessions as well. I will try my level best to give you the best experience. Okay. So let's get started. So first topic that we will be discussing is the compensation technique. Now when it comes to compensation technique, the important topics from where you can expect a GATE question is, the first one is the power flow through transmission line. The questions related to the power flow can be asked. They have been asked earlier as well in the GATE exam. They can be asked in the upcoming GATE exam as well. Then we have the methods of reactive power control, traveling wave, and load frequency control, LFC. So these are the important topics as far as the compensation technique, this particular topic is concerned. So let's get started with the very first question. So here I am having the first question for you. Let me read the question for you first of all. So in this question we have the single line diagram of power system which is shown below to us. Generators G1 and G2 are connected through a transmission line of impedance J.4 per unit. Then we have given load at G1 and G2, which are S1 is having 8 plus J10 per unit value and S2 is having a value of 5 plus J10 per unit. Voltage is V1 is 1 angle 45 and V2 is 1 angle 0. If power factor of G2 is 1 per unit, G2 is unity, then reactive power supplied by the capacitor will be what? That is what you have to find out and you have to answer in per unit. Okay. So this is the question that I have for you. So Naru and Nayan, first of all, I would like you to answer the question, okay? And then I will solve the questions for you. So I am giving you a time of 2 seconds, 2 minutes. And let me see whether you people are able to solve this question or not. So your time starts right now. The purpose of these sessions are to make you aware of the concepts and the questions that are probable to come in the upcoming GATE exam. So if you are really able to solve this question, hi Asutosh, very good evening. So if you are really able to solve these questions, you are in extremely good touch of the subject. Okay, and if you are able, even if you are able to try out this question, you are reaching up to the answer, even then your preparation is up to the very fine level. Okay. Hello Pratik, very good evening. So just try this question. Okay, this is a very important question. So many times this particular question has been asked in the GATE exam, and I'm hoping this to come in the upcoming GATE exam as well. Very good evening, Jagdish. Let me be aside so that you can have a full view of this question. So last 50 seconds are remaining. Okay. Even though this seems to be a very calculative question, but when I will answer this, you will really feel bad about yourself, because it does not involve a lot of calculation. It actually does not involve a lot of calculations. So last 20 seconds. Last 10 seconds, guys. So I didn't get any answer. So let me answer this question, okay? So guys, if you see, there must be a power, reactive power flowing across this line, and let me call this power to be QT, okay? One power may be at the generator side, let me call this QG2. And you know, we have been given that the power factor of generator G2 is 1. So what will be the value of QG2? That will be 0, isn't it? So from the given data, you can extract this information immediately, isn't it? The power factor of generator G2 is given to be 1. So what will be the reactive power supplied by G2 or absorbed by G2? It will be 0, isn't it? Now, the load at the receiving side is also taking some reactive power, and what is that reactive power? This reactive power will be, because S2 is having a value 5 plus J10, okay, P plus JQ. So what will be the value of this Q2, QS2? This is having a value of 10 per unit. Now we have to calculate how much reactive power this capacitor is providing, or how much compensation it is providing, isn't it? So this is actually, very good evening Shashi. So this is actually the power flow at the receiving end. Now if you see, we have QT plus QG2 plus QC. This is equal to QS2, isn't it? Now QT we don't know, but the QG2 is 0, and QC is what we have to calculate. QS2 value is we already having. So this is what, 10 per unit. So from here QC will be what? QC will be 10 minus Q of T. Now we have to calculate what will be the value of QT. So for that, if we want to calculate how much power is being transferred from sending end to the receiving end, for that we have a very popular formula. QT is Vs into Vr over X cos del minus Vr square by X. Do we have the value of Vr, Vs, X and del? Of course we have, because V1 is given to us, which is 1 angle 45, and V2 is having a value 1 angle 0. So this will act as Vs and this will act as Vr. So we have 1 into 1. The value of X is J.4, that is 0.4 here, cos the value of del is 45 minus 1 square divided by 0.4. So once you will solve it, you will get a value of minus 0.73 per unit. Okay, I have already done all the calculation so that we can discuss more number of questions. Okay, so this is coming out to be minus 0.73. Now what you have to do, you have to come again here and you have to put the values. So what is the value of QT? QT value is minus 0.73 here. So what will be the value of QC? The QC value will be 10.73 per unit. So this is what is needed to be done here. This is how we will solve this problem. I hope you have got the concept which has been used here. So did you like this question, student? Just answer me. Did you like the quality of this question? This kind of question you can expect in the upcoming GATE exam. So is there any doubt regarding this question? How to solve this question? Very good, Naru. Very good. Very good. Is there any doubt? Very good. Very good, Asutosh. Are you getting the same answer as well? Very good. So let me move to the next question. Now see this particular question. Very good, very good. So see this particular question. So let me read the question for you first. In this question, it has been said that a power station is shown in figure below. The station is connected with load through a 440 kV double circuit transmission line of length 200 km. So we can see in this figure, we have a generator, a transformer, a double circuit line, and then we have a transformer, then there is a load. Now, it has been said that if the initial real power transfer is 0.72 per unit at 0.8 power factor lagging at the load bus voltage of 1 per unit, then maximum power transfer will be what? Then what will be the maximum power transfer? That is what we have to calculate. So let me give you one hint for solving this problem. What we have to find out is what will be the value of P max, the maximum power transfer, and that we calculate by EV upon X equivalent, isn't it? So this is the formula by using which you can answer this question. And let me give you one more hint. The load power is also given to you. So if we apply P equals to VI cos phi at the load end, the load current will be P upon V cos phi. So P is given to you, which is 0.7. P is given to you, which is 0.72 here. And the voltage is 1 per unit and the power factor is 0.8. So the value of current will be what? The value of current from here will be 0.9. And we can write the value of current as its magnitude will be 0.9 and the angle will be minus cos inverse of 0.8. Okay. So how much value of current we will be getting? From here you will get the value of current to be 0.9 angle minus 36.86. So that will be the value of current. So this is what you have to calculate and this is the value of current. Okay. So this much hint I have given you. Now your time starts and tell me what will be the value of P max. So again I am giving you 2 minutes to solve this problem. And your time starts now. So with these hints, can you solve this problem for me? Let me be aside so that you can have a full view of this problem. So this much of hint I have given you. Now it's up to you. This can be solved within 2 minutes. So let me see who can solve this problem. Asutosh, Naru, Nayan, Shashi, Jagdish, Pratik. Over to you guys. Can you solve this question with these number of hints? So last 1 minute is remaining. Nitin Mishra is getting 1.85 per unit. 1.85 per unit means option C. Okay, let other answers, and then we will see whether option C is correct or we have any other options to be correct. So we have last 10 seconds left, guys. Hurry up. So I got answer from only Nitin side and he says option C is correct. Okay, so let me see whether C is correct or we have something else. So we have calculated the value of current here, and the value of current is 0.9 angle minus 36.86 degree. Okay, this is the value of current. Now looking into this one line diagram, if you draw the equivalent circuit, not getting, okay. Let me explain, Naru. So we have this one line diagram. From this we can draw the equivalent circuit, and the equivalent circuit will be, we have a generator here and we have the generator reactance Xg1, then we have the transformer, and then we have the double circuit line, and then again we have the transformer T2, and then we have the load. So this will be the equivalent circuit of this particular single line diagram. So here we have the value of Xt1, which is 0.2 per unit. The value of Xg is how much? 0.5 per unit. What is the value of line reactance 1? It is 0.6, and the value of line reactance 2 is also 0.6. The value of Xt2 is 0.2 here, and here we have V. Okay. So looking into this particular diagram, can you tell me what will be the X equivalent here? So if you calculate X equivalent, that will be 0.5 the generator reactance plus the transformer reactance plus the parallel combination of this line reactance plus the transformer 2 reactance, isn't it? So this will be the equivalent reactance, from which you will get 1.2 per unit of X equivalent. Are you getting the same answer? Very good. So this will be 1.2 per unit. Okay. Now we have to calculate P max, maximum power transferred. We have to calculate P max, maximum power transferred from the sending end to the load, and that we will calculate by using the formula EV upon X equivalent. So guys, P max is what? P max is basically E into V upon X equivalent. So we have calculated what is X equivalent. We know the value of V, which is 1 per unit. Now we have to calculate what will be the value of E. So if somehow we can calculate the value of E, we will be able to answer it. So how do we calculate the value of E? So the value of E will be V plus J X equivalent into I, isn't it? Because the current flowing here is what? The current flowing here is I, and we have all the values. So what is V? V is basically 1 plus J, 1 angle 0. J X equivalent is 1.2, and the value of I that we have is 0.9 angle minus 36.86. So you have to solve this equation and then you will get the value of E. So I have already calculated this, and this is coming out to be 1.85 the magnitude, and the angle is 27.67. You can verify these answers later on because it involves a lot of calculation. So if I will be calculating everything here, it will take a lot of time, and ultimately we will not be discussing so much questions that we wanted to. Okay. Good evening, Subodh. So I have done the calculation, and E is coming out to be 1.85 angle 27.67 degree. So do we have the required data right now? Of course we have, because we have the value of E, which is 1.85. We have the value of V, which is 1, and the X equivalent that we have calculated is 1.2. So from here, if you solve this, you will get 1.54 per unit of the maximum power. You will get 1.54 per unit of the maximum power, I think, which is option number D. So Nitin, your answer is wrong. Option D is correct here. So whether Nilmesh, Nayan, Asutosh, are you getting the same answer, guys? P max will be 1.454 per unit. And tell me whether you have understand what is required to be done here in this problem, because I am expecting this kind of problem in the upcoming GATE exam. So did you get what is required to be done here? Very good. Very good. Very good. So everybody is getting the concept. Very good. Very good, Asutosh. So this is time to move to the next problem. Now, this is a very good concept because it is going to teach you a lot of concepts, and any of these things can be asked in the exam. Okay. So what has been given in this exam, let me just read the question for you. A transmission line has impedance of 3 plus J4 ohm per phase, and it is connected with 10 megawatt 0.8 leading power factor load as shown in the figure. So we have the transmission line whose impedance is 3 plus J4 ohm, and it is connected with a load of 10 megawatt 0.8 leading power factor. Now what will be the value of load angle del? What will be the value of load angle del, and how much compensation is required in order to maintain VR equals to Vs equals to 33 kV? That is what we have to calculate. Very good, Nitin. That is what we have to calculate. So we have a generator which is supplying a load through a transmission line of impedance 3 plus J4 ohm. In order to maintain the receiving end and the sending end voltage equal to each other, how much compensation will be required and what will be the value of the load angle del? That is what we have to calculate here. Okay, that is what we have to calculate here. So again, I am giving you some time to solve this problem, and this time I am giving you 3 minutes, and let me check whether you are able to solve this question or not. Your time starts now. How much compensation will be required and what will be the value of load angle del? That is what you have to calculate, and the required data is given in this problem. So guys, solve this problem and tell me what will be the answers. So we have 2 minutes left. From the given load, you can calculate the requirement of reactive power that the load. Naru has got one answer. He's saying B is correct. So B is the answer for the required compensation, isn't it? Now what is the value of del needed? Asutosh is saying the angle is 2.63. The angle is 2.63. The load angle is 2.63. Let me check whether the angle is 2.63 or not. So we have got two answers, the required compensation and the load angle. Naru is saying option A. So let the other answers, and then we will check whether A is correct or B is correct. Okay, this is an MSQ type of question, isn't it? Because we have to calculate the load angle, so we have two options for load angle and we have two answers for compensation required as well. Okay, Okay, so let me answer this question. So guys, as per the load requirement, we can calculate the Q load, isn't it? What will be the reactive power requirement of the load? That will be calculated by the formula P tan phi. So what is P? P is basically 10 megawatt, and tan, what will be the value of phi? Phi will be cos inverse 0.8. So this is coming out to be how much? This is coming out to be minus 7.5 MVAR. Minus 7.5 MVAR. Minus because of the power factor is leading, so the load must be supplying the reactive power instead of absorbing the reactive power. So we have to put the minus sign here, and apart from that we have the impedance value Z. Z is how much? Z is basically 3 plus J4 ohm per phase. So from here what we can write? From here we can write 5 angle 53.313, that will be the value of Z. So if we compare Z with B angle beta, then what will be the value of B here? The value of B here will be 5 and the value of beta will be 53.13. Now value of A, as you know, is we will take it 1 angle 0 unless stated otherwise. So that information we can extract from the given data. Now you know that we have a formula for the power transferred, and that is what? That is Vs Vr upon B cos beta minus del minus A Vr square upon B cos beta minus alpha. So by using this formula, let us see what we can calculate. So what do we have? A is 1 angle 0 means 1 angle alpha. So what will be the value of alpha? Alpha's value is 0 and A value is 1 here. So put the values that we have. What is the value of PR? It is 10. Vs, Vr both are maintained at 33. Value of B is 5. Cos beta. Beta value we have 53.13 minus del. What is the value of del? Del value we don't know. We have to calculate it. Minus A value is 1, again VR is 33 divided by 5, and then we have cos 53.13 and the value of alpha is 0. So in this equation, if you see, only one unknown is there, and that unknown is the value of delta. So the delta value that is coming out to be after solving this equation is 2.93 degrees. The delta value coming out to be 2.93 degree, but we don't have any value in the answer. Okay, so I will reveal that thing later. So delta value we have obtained, guys. Delta value we have obtained. Did you get how did we get the value of the delta? Is that understood? How we get the value of delta? So delta we have calculated. Now we have to calculate how much is the Q line. Okay, how much is the reactive power flowing in the line? So for that we can use another formula. So you know that the value of Q line, how to calculate the value of Q line? Q line we can calculate, or let me call this QT. Q line is also equals to QT, and that we can calculate by Vs Vr upon B. The same formula will be there, but instead of cos we will use sin now. Sin beta minus del minus AVR square upon B sin beta minus alpha. So that is the required formula that we have. Now put the values here. Now put the values here and see what will be the value of Q line here, or QT. So Vs Vr, these are 33. B value is 5. Sin beta is 53.13 minus del we have calculated right now. Minus A is 1, Vr is 33 square divided by 5, sin beta is 53.13 minus 0. So from here if you calculate the Q line, that value is coming out to be minus 8.71 MVAR. Minus 8.71 MVAR. Okay. So this is how we can calculate what will be the value of Q line. Now we have the value of Q line. What is the value of Q line here? The value of Q line, or we can say the QT, that value is minus 8.71 MVAR. Load is 10 megawatt, 0.8 power factor leading. So load is providing power to the system, and that reactive power is how much? Q load. Q load is how much, guys? The Q load value we have calculated, and this value is how much? This value is minus 7.5. So this is minus 7.5 MVAR. Okay. Let me write the power here to be QR. Okay. Now you know what I have taught you, that QR is what? QR is basically the difference of reactive power requirement of the load minus the reactive power supplied by the source or the reactive power flowing into the line, isn't it? So what is QR? At this point, receiving point, what will be the value of QR? It is basically the difference of the requirement of the load to the supplied by the source, isn't it? The difference of the reactive power requirement of the load and the reactive power supplied by the source. Okay. So if we calculate this, how much is the Q load we have? Q load that we have is minus 7.5 minus how much QT we have? It is minus 8.71. So after that you will get 1.21 MVAR. Now if you see, this is positive. So if this is coming out to be positive, what does that mean? If suppose this is coming out to be positive, can anybody tell me what does it mean? If this QR is positive, if this QR is positive, that means whatever is the reactive power requirement of the load and whatever has been supplied by the source, this is the difference of QR. Now if QR is coming positive, can anybody tell me what it actually means? Nilmesh is saying capacitive compensation. Absolutely correct. Okay, that means I'm asking what it actually means. Delivers power. If suppose this QR has been negative, what it actually means? It means whatever is the requirement of the load, actually the source is supplying more power, isn't it? But it is coming positive here. That means whatever is the requirement of the load, the source is not able to supply that much. So there is a deficit of power. Very good, Nilmesh. There is a deficit of power at this point. So when there is a deficit of reactive power, what we need to do? We need to provide it externally. And who provides the reactive power externally? It is the capacitor. So what we do? We will connect a capacitor here, and the rest of the things will be done. So how much compensation is required? The answer is 1.2 MVAR. That is the compensation required here. So that will be the value of QC. That much compensation is required here. And which type of compensation is required? The answer is capacitive. If QR is coming positive, so the difference that we have taken from there, you can just take an interpretation that whatever is the requirement of the load, that is not being supplied exactly by the source. So there is a deficit of power. So for that, we will connect a capacitor, because capacitor provides the reactive power. If suppose this would have been negative, that means whatever is the requirement of the load, actually the source is supplying more than that. So for that, we have more excess power at the receiving end. So if we have excess power, we have to take that power out from the receiving end. So who will take that power out of the receiving end? Who is able to absorb the power? So we know that the inductor absorbs the reactive power. So we will connect inductor if this Q is coming out to be negative. So the purpose of taking this particular question is to clear all these concepts of yours, because you can expect this question from any of this topic. This is a versatile question. It has so many concepts, mixed concept question. You can get a question and from any one of this topic. Okay. So this is a very, very good question. But what happens in the options? If you see, we don't have any options, isn't it? In the options, if you see, we don't have any option. The del value is coming out to be 2.93, and the compensation required is how much? It is 1.21 MVAR. So none of the options are having the same answer. So this is a typing mistake that I have here in this question. But if suppose this kind of scenario, if you are facing this kind of scenario in the GATE exam, you will get full marks for this question. Okay. So if such a scenario you are facing in the GATE exam, do not waste your time by recalculating again and again and checking your answer whether you have done any mistake or not. Okay, once you can do this, but you need not to waste your time. Sometimes this happens. So what happens if this is the case? You will be awarded full marks. Okay, so tell me guys whether you have got this particular question and its solution. Did you get the concept required? This is a multi-concept question. You can expect a question from any one of the concept. Okay, this complete question may not be there in the GATE exam because it requires more time to solve it, but any one of this concept may be utilized to make a questions, and you can expect these concepts in the exam. Very good, Nilmesh, very good. So this question is done. So the required formulas you have to remember guys. Okay, and it's very easy to remember the required formula. Now see this particular question. Let me read this question first for you, and then I can see, then I will wait for your answers. Okay, so what this particular question says is that we have 5 identical generators that supply power in a system having lossless transmission lines. Generator 1 is equipped with a speed governor that maintains its speed constant at the rated value. So generator 1 is maintaining the speed constant. That means its droop will be how much? Can anybody tell me? If the generator 1 is maintaining constant speed, then what will be the droop of this generator? Okay, I'll wait for your answer. Very good, Nilmesh. It will be 0%. Very good. Whereas generator 2 and 3, they have a droop of 2% and 3%. Generator 4 and 5 have governors with droop of 4% and 6% respectively for a given increase in system load at steady state. So we have 5 generators. Very good, Asutosh. So we have 5 generators, and whatever their respective droops are, they are also given to us. Now we have to comment if suppose there is a sudden increase in the load, then what will happen. So option A says all generators will share the increased load equally. Option B says generators 1, 2, 3, 4, 5 will share the increased load in the sequence of 1, 2, 3, 4, 5. Means first generator 1 will be loaded, then second, then third, then fourth, and then 5. And option C says generator 1, 2, 3, 5 will share the increased load in the sequence. First 5 will be loaded, then 4, then 3, then 2, and last we are loading to we are giving the load to the generator 1. And option D says generator 5 will share the entire load and the output of other generators remains unchanged. Okay, so let me check who can answer this question, and I am giving only 1 minute for this because it does not require more than this time. So let me see who can answer this question correctly. Asutosh is saying option C is correct. So Asutosh is giving the increased load to the generator 5 first, and he is loading to the generator 1 at the end. Nilmesh, Naru, Nayan, what is your answer? Neha, Nitin, Nilmesh is saying option B is correct. Thank you, Prateek. So I'm sure you guys are really liking these questions, isn't it? So we are left with last 20 seconds, guys. So let me see who can answer this correctly. We have 2 answers. Nilmesh is saying B and Asutosh is saying C. So Nilmesh, your answer is correct. Naru or Nilmesh, your answer is correct. Okay, it is B which is correct here. So what is the required concept? Asutosh, why you have committed a mistake here? What is the concept required here? If suppose I draw the droop characteristic here, on the x-axis I am having power, and on the y-axis I am having frequencies. So what do we have? We have generator 1 with 0% droop. This is generator 1 with 0% droop. Then we have generator 2. Then we have 2 and 3 with 2% and 3% droop. So this is generator 2 with 2% droop, and this is generator 3 with 3% droop, and after that we have generator 4 which is having how much droop? 4 and 6%. So generator 4 is having a droop of 4%, and generator 6 we have which is having a droop of, generator 5 is having a droop of 6%. So these are the different droop characteristics that we have. These are the different droop characteristics for all the 5 generators that we have. Now we have to comment which, if there is a sudden increase in the load, which generator will share the maximum load. Okay. So if suppose in the option there would have been an option that generator 1 will share all the load, then we would have corrected that. Okay, we would have taken that option to be the right option, because the generator is having the minimum droop that will share the maximum load. Just remember this concept, the generator will have minimum droop that will share the maximum load. So here the generator 1 is having 0% droop, so in case of a sudden increase of load, generator 1 will share all the load, but it is not in the option. So comparatively, if we compare, what am I saying, what a statement I am making here? The generator with the lowest droop will share the maximum load. So if there is a sudden increase in load, guys, if there is a sudden increase in load, then who will share the maximum load? First of all, 1 will be loaded, and after that 2 will be loaded, and after that 3 will be loaded, then we have 4, and then we are loading 5 at the end, isn't it? So this will be the sequence, this will be the sequence in which the generator will be sharing the increased load, isn't it? Asutosh, did you get why B is correct here? Did you get why B is correct here? So B is the correct answer here. So Nilmesh, Nayan, they have answered it correctly. Asutosh, did you get the fact why answer B is say correct here? Very good. Okay, so just remember this particular fact, generator with the lowest droop will share the maximum load. So if this would have been an answer, if there would have been answer here, option here that generator 1 will share all the load, we would not have gone through any other option. That option we will be ticking here, isn't it? But here they are sharing the load among all the generators. So in which sequence the load will be shared? So that is what we have to answer here. So I hope that you people have got the required concept and the way how we can solve this problem. Now moving towards the next problem, let me read the problem first for you, and it says a 100 MVA alternator operated at full load on 50 Hz. The inertia constant H is 4 megawatt second per MVA. Delay time is 0.5 second. One of the transmission line is stripped so that the output of generator is reduced by 70 megawatt. The frequency deviation during this time will be what? That is what we have to calculate. What will be the frequency deviation? Frequency deviation means del F, means what is the new frequency when, and what was the initial frequency. We have to take the difference of that. So can you guys solve this problem for me? And your time starts now. Only 1 minute is sufficient to solve this problem. From last few years, we are not getting any question from this particular concept. So I am expecting this year, this particular concept will definitely give you a question. Okay. So this is a very important concept for the upcoming GATE exam. Now let me see whether you are able to solve this question or not. Okay. So I'm waiting for your answer, guys. Last 30 minutes, last 30 seconds are left. So let me check who can give the correct answer for this question. So what is the required formula here? the required formula here is the new frequency is calculated by this formula. The new frequency is equals to the initial frequency h into s minus del PD into TD divided by h into s power 1 by 2. Okay. Now, where del PD is what? Del PD you will take positive for sudden load demand. Okay. If sudden load is demanded, you will take it positive, and if there is a load loss or loss of load, then you will take it negative. So what is the case here? If you read the question, it has been said that the output of the generator is reduced by 70 megawatt. So what will be the value of del PD here? The output is reduced by 70 megawatt. So earlier it was 100 MVA. If we assume the power factor to be 1, let us take it 1. 100 megawatt, it has been reduced to what? It has been reduced to only reduced by 70%. So it will be 30. So there is a loss of load. So we will take a negative sign before as well. Okay. Now, do we have all the values here? What is the initial frequency? Initial frequency is 50 hertz. Value of h, the inertia constant is 4. Value of s is 100 minus del PD is minus 30. Time delay is given to us, which is 0.5 divided by 4 into 100 power 1 by 2. So after solving this, you will get new frequency to be 50.92. So that will be the new frequency. So can you tell me what will be the frequency deviation? It will be 50.92 minus 50, that is 0.92 hertz. So do we have any options which has the same option? Yes, we have the option C, which is the correct option here. 0.92 hertz will be the frequency deviation. Okay. So all you need to do is to remember this formula, guys. If you are able to remember this formula, pretty easily you can solve this problem. Nothing else is required here, and you have to remember this fact: del PD. Okay, Nilmesh. So just remember this formula. If this is a new question for you, by remembering this formula, you can solve this question. Okay, this belongs to the chapter load flow control, from the topic load frequency control. Okay, load frequency control. All you need to remember is del PD. Okay, del PD you will take it positive if there is a sudden load demand, and you will take it negative if there is a sudden load loss. Okay. So this is how we can solve this problem pretty easily, isn't it? Now moving towards the next problem. Now this is a kind of questions. This is a kind of question, or I should say this is a kind of topic from where every year there is no such paper in GATE Electrical where we haven't got any question from this particular topic. So this is a very important topic. Although we have a similar kind of question in the GATE exam, but I just want you to practice this topic, this kind of questions, so that if this would have been there in the GATE exam, GATE 2023 exam, and of course this would be there in the GATE exam, so you will be able to solve it pretty easily without wasting your time. Okay. So let me just read this question for you. We have two alternators rated for 160 megawatt and 120 megawatt respectively. So these are the rating of two alternator, 160 megawatt and 120 megawatt, connected in parallel to share a load of 250 megawatt. They are connected in parallel and they are sharing a load of 250 megawatt. Okay. The larger unit has a governor droop of 5%. While the smaller has a droop of 4%. So for first generator, that is for 160 megawatt generator, the drop in frequency will be what? 5% of 50. And for lower generator, for 120 megawatt generator, the drop in frequency will be what? 4%. So 4% of 50, that will be dropped. So it is basically operating at 47.5 hertz and it is operating at 48 hertz in the frequency from no load to full load. The load shared by smaller unit will be what? That is what we have to calculate. So how much load will be shared by the lower unit? That is what we have to calculate. Although we have The similar kind of question been asked in the GATE exam so many times, but yet I want you to practice this kind of question, because again you will get the same kind of question in the upcoming GATE exam. So do practice such kind of question as well, guys. So can you solve this for me? Because this is a very popular question. So I am giving you 2 minutes, and let me check whether you are able to solve this question or not. So you have 2 minutes. So let me check who can solve this question. This is a very popular concept from which regularly we are having GATE questions. The no load frequency is 50 Hertz, okay, and generator 1 is having a droop of 5%, means its frequency will be dropped by 5% when it is loaded. So earlier it was operating at 50 Hertz. Now when it is loaded, its frequency will drop by 5%. So what is the 5% of 50? It is 2.5. So what will be the frequency at which generator 1 is operating? 50 minus 2.5, that is 47.5. Similarly, generator 2 is having a droop of 4%. So at what frequency it will be operating? 50 minus 4% of 50, that is 48. So we have last 1 minute left. Let me see who can answer this question. And increase your speed, guys. Increase your speed. This question only required 2 minutes to be solved. So we have last 20 seconds left. So see, what do we have here? If I draw the droop curve, so the no load frequency given to us is 50 Hertz. Okay. Now we have one generator which is operating at a droop of 5%. This is having a droop of 5% and its rating is 160 megawatt. Okay. Its rating is 160 megawatt. Other generator that we have is operating at a droop of 4% and its rating is 120 megawatt. This is operating at 4% droop. So it will be sharing a load of 160 megawatt at somewhat frequency 47.5 Hertz, and this is sharing this particular load at a frequency of 48 Hertz, isn't it? So do we have this scenario here? Generator 1 is operating at 5% droop, means it is sharing 160 watt of load at 5% less of the frequency. Similarly, generator 2 is operating at 4% droop, it means it is sharing the load at somewhat 4% less frequency. So how much is the 5% and 4% of 50? That will be 47.5 and 48 Hertz. I hope this you got this concept. Okay. Now they are when they are operating in parallel. So be very clear, when they are operating in parallel, they will be operating at the same frequency, isn't it? Let that frequency be Fn. Okay. At that frequency, if suppose at that frequency Fn at which they are operating in parallel, if this is sharing a load of PB, then what will be the load shared by this particular alternator? Let this be PA. Okay, let this be PA. So we have PA plus PB. We have PA plus PB. How much? When they are operating in parallel, they have to share a load of 250 megawatt. So when they are operating in parallel, they have to share the load of 250 megawatt. This is what we have. Nilmesh has got an answer, 121. Okay, very good, Nilmesh. 121 is the correct answer. Do we have any option? 122 is the nearest answer. Okay, so that will be the correct option. Very good. So let me check what we are getting from here. Guys, if this is the theta 1 angle, then this shall be also theta 1. If this is theta 2 angle, then this shall be also theta 2, isn't it? So from here, if we obtain theta 1, tan theta 1, so from tan theta 1, from the last angle, what will be the value of it? It will be 50 minus 47.5 divided by 160, and also from the smaller triangle we can calculate it by 50 minus Fn, this is divided by PA. Okay, so that is what we will get. So from here, if I calculate what will be the value of 50 minus Fn, so that value we will get 2.5 divided by 160 PA. So that will be the value of 50 minus Fn here. Now in the second, for the second case, if we calculate tan theta 2 here, so in the second case, tan theta 2 from the bigger triangle, that we will get 50 minus 48 divided by how much? 120. And this is equals to, from the smaller triangle we will be having 50 minus Fn divided by how much? PB. Okay, so from here what do we have? Where here we have 50 minus Fn, this is equals to 2 by 120 PB. Okay, so here also we have 50 minus Fn, here also we are having 50 minus Fn, so we can equate them. So once we will equate them, what do we get? We will get 2.5 PA divided by 160, this is equals to how much? This is equals to 2 by 120 into PB. So we have equation 1 and we have equation 2. So once you will solve equation 1 and 2, you will get the value of PB. So we required the value of PB only, so need not to calculate PA. But if you want to calculate, you can calculate. So PB value is coming out to be 121.43 megawatt, which is the closest to 122. So answer will be 122. And I think Neelmesh has got almost the same answer. So here option A is correct. Okay, very good Neelmesh. Keep up this spirit. Very good. You are almost getting the correct answer in each of the questions. Very good. Excellent. So this is how you will solve these kind of questions. Okay, this is how you will solve these kind of questions, guys. So be ready for these kind of question. Every year, almost every GATE paper has a question from this particular topic. So be ready. You will also get a question from this topic. Now, how to solve this question, I have very easily explained this to you. So is that clear? Give me a reply. Is that clear? Do you have any problem up till now in this topic? And very good Neelmesh, you are in great touch of this subject. Very good. So do you have any doubt? Is there any doubt or everything is clear here? So if you are clear with all the concept, let me give you the similar kind of question and let me check whether you are able to solve this question or not. So what it says is, there are two generators in a power system. No load frequencies of the generators are 51 Hz and 50.8 Hz respectively, and both are having droop constant of 0.86 Hz per megawatt. Total load in the system is 3 megawatt. Assuming that the generators are operating under their respective droop characteristic, the frequency of the power system in Hertz will be what? So this is the same kind of problem, but it has been asked in somewhat a different manner, isn't it? It belongs to the same concept, but what has been given to us? Now we are given with the no load frequencies at which the generators are operating. Okay, earlier the no load frequency was same, it was 50 Hz. Now we have different no load frequencies. So we will draw the droop characteristic in somewhat different manner. Okay, so we have now different droop characteristic with that, and what has been given to us is PA plus PB, or let me say that yes, PA plus PB. PA plus PB is what here? Both the generators are sharing 3 megawatt combined. Okay, let me take the share of generator 1 to be PA and share of generator 2 to be P2. So both are sharing a load of 3 megawatt. Okay. So let me draw the droop curve first and the things will be very, very clear to us. So if I draw the droop curve where this is P in megawatt and this is F in hertz. So what do we have here? Generator, no load frequencies of generators are 51 and 50.8. So one generator is operating at 51 hertz and it is sharing a load of how much? Let us consider that it is sharing a load of PA and it is operating as 51 hertz. Other generator is operating at a frequency of 50.8. So it is operating at a frequency of 50.8. This is, we are talking about generator A. This is, we are talking about generator B. And here it is sharing a load of how much? It is sharing a load of, let us consider PB megawatt. Okay. So now here we have this particular situation. Now when they are operating in parallel, what will be their common frequency at which they are operating? That is what we have to calculate. So we have to calculate the value of Fn. What will be the value of Fn here? That is what we have to calculate. Yes. So I have depicted the problem for you and now I am giving you time. So let me give you 2 minutes and let me check who can solve these problems. So you have 2 minutes to solve this and I have given you a hint how you can solve this question. So let me check who can answer this question. So we are left with 1 minute. Hurry up. In the last question, the no load frequency was same. So we have drawn the droop curve in somewhat different manner. Here the no load frequencies are different. So that is why we have drawn this kind of droop curve. So Nilmesh is getting an answer 32 hertz. Okay. Now guys, see here. Let me call this angle to be theta 1 and let me call this angle to be theta 2 here. So how can we obtain tan theta 1 here? So tan theta 1 here will be 51 minus Fn divided by how much? 51 minus Fn divided by how much? Divided by P1, isn't it? Isn't it? This is up to you whether you are taking P1 here or you are taking P1 here. Okay. There is don't be very clear with this fact. Okay. You can draw this like this as well. If you are getting confused here, you can draw this like this as well. No problem in this. This is PA and this is PB. Okay. So if you are getting a problem here, no problem. You need not to have confused with this particular fact. So what will be tan theta 1 here? 51 minus Fn divided by how much? Divided by PA. Okay. And if you see, this is frequency in hertz and this is power in megawatt. So hertz per megawatt, this is what? Droop constant. And we are given with the droop constant. Droop constant is how much? It is 0.86. So we can equate this with 0.86. Okay. We can equate this with 0.86 and from here we can get the value of PA. So what will be the value of PA here? The PA value here will be 51 minus Fn divided by 0.86. Let me call this to be the equation number 1. Now from the second case, what will be the value of tan theta 2? So from the second case, the value of tan theta 2 will be 50.8 minus how much? Fn divided by Pb, okay, divided by Pb, and that is also hertz by megawatt. That is the droop constant. Droop constant is how much? It is 0.86. It is 0.86. Okay. Now we can make a small change here. We can also write 50.8 minus Fn. What will be the value of Pb? Pa plus Pb combined, they are sharing a load of 3 megawatts. So what will be the value of Pb? It will be 3 minus Pa, and now that is equals to 0.86. Now let me call this to be the equation number 2. The Pa value you can put from equation 1. So from equation 1 and 2 you can solve these two equations. From equation 1 and 2 you can solve these two equations. You can put the value of Pa from equation 1. Then only unknown left is Fn, and Fn is now coming out to be 49.51 hertz. So that is the correct answer. That is the correct answer. Okay, 49.51, that is the correct answer. And I am getting the same answer from Naru side right now. Okay, earlier he said that 32 hertz will be the answer, but he corrected his answer, and now he is also getting the same answer. So did you guys get what concept is required here? See, this is a very popular topic from the power system as far as the GATE exam is concerned, and you can get only these two types of question. First one is this question where we have different no load frequencies. So either the question will be asked in this particular manner or in this particular way that we have done earlier. Okay, where we are having the same no load frequency and load sharing will be asked, or this type of questions where we are having different no load frequencies, droop constant is given, and we have to answer what will be the common frequency at which the generators are operating in parallel. So did you guys get all these concepts? Tell me, answer me first of all. Nayan, Asutosh, Nilmesh, Pratik, Neha, Nitin, did you guys get this concept? How to tackle these kinds of problem, because these are very, very important concept, and I'm very sure in the year 2023 you will definitely get again a question from this topic consisting 2 marks attached with it. Okay, this is a very important concept. Very good, very good, Asutosh. So now moving towards the next problem. Now I am expecting this problem in this particular year 2023. Okay, very good, Nayan, very good, Asutosh. So let me just read this problem for you. A 132 kV transmission line has inductance and capacitance of 0.1 millihenry and 0.02 microfarad per phase. The surge impedance loading in megawatt after placing 20% shunt capacitive compensation will be what? That is what we have to calculate. So we have to calculate the surge impedance loading once we have placed 20% shunt capacitance. That is what we have to calculate. Okay, so what is the required formula? So what will be the surge impedance without compensation? So if we talk about without compensation things, so without compensation, what will be the surge impedance? So if we calculate the surge impedance without compensation, that is ZS1, which is equals to under root L by C. So what is the value of L that we have? 0.1 into 10 to the power minus 3 divided by what is the value of C that we have? 0.02 microfarad. So from here you can get the value of ZS required, and the value of ZS coming out to be 70.71 ohm. So that is the value of ZS that we have. Now what will be the value of surge impedance loading without compensation? That we will calculate by Vs square upon ZS1, and mind the fact that here we have to take the line values, which is 132 kV here. So 132 square kV, we can write 10 to the power 3 square divided by 70.7 here. So SIL1 will be, SIL1 that we have is 246.4 megawatt. So these are the things that we have without compensation. Sir, I have previously done the questions of load frequency control, but I haven't yet revised it. Okay, so now you are getting the things revised as well, Naru. And that is the purpose of this gate score booster series. So I believe that this gate score booster series is really serving its purpose. Okay, that is the purpose of this series, and it's really serving its purpose. Very good. So coming back to this question, so now with compensation we have this situation. Okay, now without compensation, now what will be the condition with compensation? So for that you need to remember one formula, guys. With compensation, what will happen here? With compensation, the SIL2 means the new SIL, that will be the SIL1, that is the old SIL, and what we have to do is we have to add this factor, and that is 1 plus KCSH upon 1 minus KSE and 1 minus KLSH. Okay, where what is KCSH? It is the degree of shunt capacitor compensation. What is KSE? It is the degree of series capacitor compensation. What is KLSH? It is the degree of the shunt reactor compensation. So in our case, what type of compensation we have used? We have used the shunt capacitive compensation, isn't it? So we are using shunt capacitive compensation, and the degree of shunt capacitive compensation is 20%, that is 0.2. So all we need to do is, so we will remove this factor, and we will keep only this particular thing in our formula. So SIL1 is what? SIL1 we have already calculated, 246.4, and under root 1 plus 0.2, that will be there. So once you will solve it, you will get 269.92 megawatt of new SIL value, which is there in the option B. So option B is the correct option. So in order to solve these kind of questions, all you need to remember is this particular formula. Now you can get this particular question in the GATE exam. Instead of the shunt capacitive compensation, it might be shunt reactive compensation, shunt inductive compensation, or it might be a series capacitive compensation. So whatever has been given to you and what is not there, you have to remove them. If suppose we have all kind of compensation present in a problem, we have to use everything here, isn't it? So you have to remember this one formula, and you can solve n number of problems. Whatever is the compensation used, you have to only keep that. You have to remove all others. If suppose all type of compensation are used, that might be the case, then you have to take all these present here. So this is how we will solve these kind of question. So did you guys get the fact how to solve these kind of question? Give me a reply. Did you get how to solve these kind of question? And isn't it a very nice question as well? Give me a reply. Very good, very good. So moving towards the next problem that we have with us. Now, this is a very, very important problem. This is a very, very important problem, guys. You can get this particular problem in the upcoming GATE exam. And what has been said in this? A shunt capacitor of 50 MVAR is operated at 70% of rated voltage and 50% of rated frequency only. So it is not operating at its full contest. Okay, it is only operating at 70% of rated voltage and 50% of rated frequency only. Now what we have to do, we have to calculate the MVAR delivered by it if it is operating at this particular rating. Okay, so let me give you some time for it. It only requires 1 minute of time. Let me check whether my students can solve this question or not. So I am giving you 1 minute, and I'm very sure that you people can solve this problem very easily. So last 20 seconds, guys. It only requires 1 minute of yours. Last 10 seconds. Increase your speed, increase your speed. And the time is up. So remember the fact, if you are using shunt capacitor, okay. So if you are using shunt capacitor, or there might be a case that you might be using shunt reactor as well, or shunt inductor, let me call it. So in both these cases, the QC per phase, the reactive power per phase, in this particular case, it is proportional to V square into F. In this particular case, it is proportional to V square F. And if suppose this would have been the case, then this is proportional to V square by F. Okay. So you may get a question in GATE exam where both these are there and a comparative case might be there. In our case, we have shunt reactor. In other case, you may have a shunt inductor, or there might be a possibility you might be having both of them and you have to compare the reactive power of both the cases. So there might be a possibility. Okay. Very well done. Very well done, Nilmesh. You are getting a correct answer, but you are not answering up to the time limit that we have. Okay. This kind of question you should solve in 1 minute only. That will increase your speed and you will be able to solve more number of questions. You will be able to score more in the GATE exam. Okay. Very good. Well, 12.25 is the correct answer. So those who are not able to get what concept is required, you may get this fact. Okay. So here we have shunt capacitor. So what we have to do, we have to calculate, if we calculate Q2 by Q1, that will be V2 by V1 square into F2 by F1 here. Okay. So if you see, what will be the value of Q2 then? V2 by V1 is what? The voltage is only 70%. So V2 by V1 will be 70% only. The frequency that we have is 50% only. So here we have 50% only. Okay. So what will be the Q2 value? So finally, when you will calculate the Q2 value here, because Q1 is given to us, how much is Q1? Q1 here is 50 MVAR. So if you will calculate the value of Q2, this is coming out to be 12.25 MVAR. So this is how you will solve this particular question. Now this question may be replaced by a shunt inductor, or there is a possibility that you will get both shunt reactor, shunt inductor and shunt capacitor both present in a problem, and you have to do a comparative kind of analysis. You have to calculate a comparative kind of thing, difference of reactive power, the ratio of reactive power. So be prepared for these kind of questions, or ultimately what I want you to learn is this particular concept, because this is very important. Remember these two cases here. If this is a shunt inductor and if this is a shunt capacitor. So is that clear? Asutosh, Nayan, Nitin, everybody, are you getting this concept, how to solve these questions? Do remember this fact and you will be able to solve whatever has been asked from this concept. Okay. Yes. Now moving towards the next question. So let me read this question for you. Very good. Let me read. Nayan is saying very good question. Very good, Nayan. So let me read this particular question for you. In this question, we have a 3-phase 50 Hz 440 kV transmission line, which is 400 km long. So length of line and the operating voltage is there. The line inductance is 1 millihenry per kilometer per phase, and the line capacitance is 0.01 microfarad per kilometer per phase. The line is under open circuit condition at the receiving end and energized with 440 kV at sending end. The receiving end line voltage in kilovolt will be what? That is what we have to calculate. So I am giving 2 minutes to solve this question again to you. Okay. And I am very sure that you people can solve this question. Take your time, guys. Take your time and solve these questions. So this is almost the question number 10 from this topic, compensation techniques. Okay. So these are the concepts from where you can expect a gate question in GATE 2023 exam. So practice these concepts as much as you can. I'm not saying that you will exactly get the same question, but you can expect a question from these concepts in the upcoming GATE exam. So I have done a lot of research for the last 15 years papers, and then I have finally concluded that these concepts are very, very important concept for the GATE 2023 exam. So do practice these concepts as much as you can. Remember the fact the line is under open circuit condition here, okay? Remember this fact, the line is under open circuit condition here. So let me give you a hint. For an open circuit line, what will be the ABCD parameters? Vs equals to AVR plus BIR. Line is operating under no load. IR will be 0. Then what will be the VR? It will be Vs upon A. So you have to calculate the value of A, guys. And then you will be able to solve this problem very easily. But there is this particular case, I have seen student getting confused as well. So that is why the purpose of choosing this question is to remove your confusion as well, okay? So last 15 seconds are left. Naru is saying option B is correct. Very good. Very good. So Naru, Nilmesh, you are in a great touch of this subject. Let me appreciate this fact. Let me appreciate this fact. You are in a great touch of this subject and carry on this preparation level. And I'm very sure that you are going to rock in GATE 2023 exam. Excellent. Very good. Okay. So guys, here we have no load condition. Okay. So what will happen under no load? Under no load, what is the general ABCD constant? Vs is equals to AVR plus BIR. That is what we have. Under no load, what will happen? Generally, the no load condition IR will be 0. So in that case, if you put IR to be 0, you will get the VR voltage. This is equals to Vs upon A. So we have to calculate the receiving end voltage, and that is equals to Vs upon A. Sending end voltage is given to us 440 kV. The only value that we have to calculate is A. Now the question arises how to calculate the value of A. So what we have, the conclusion that we have arrived that VR, that is what we have to calculate, this will be equals to Vs upon A. Now we require the value of A for that. So you know that the length of line is how much? The length of line is given to us, which is 400 kilometer, and the operating frequency is 50 hertz. So this is what? This is a long transmission line. So in case of a long transmission line, if it is represented by its equivalent pi model, what is the value of A? The value of A is 1 plus YZ by 2, isn't it? Now, since the line is having line inductance and capacitance, so since the line is lossless line, so what we can do, generally the value of Y is what? G plus J omega C, and generally the value of Z is what? R plus J omega L. So since the line is lossless line, so for a lossless line, what do we have? For a lossless line, the value of R is 0 and the value of G is 0. So what we will do, we will put the value of J omega C and J omega L only here. So ultimately you will get 1 minus omega square LC by 2. 1 minus omega square LC by 2. And one more thing, the propagation constant, you know, it is equals to what? Y into Z, or it is equals to alpha plus J beta. So I am revising all your concept here. So once you will put the values, you will get the value of beta equals to omega under root LC, or beta square will be omega square LC. So this is what? This is equals to 1 minus beta square by 2, isn't it? So this is equals to 1 minus beta square by 2. So all you need to do is to calculate the value of beta. Now what is the value of beta? what is the value of beta? So beta value you can calculate by 2 pi f into L divided by V. Now what is the value of V? V value you can calculate simply by putting 1 by under root LC. So if we put the value of L and C here, what is the value of L? L value here is 1 millihenry per kilometer and C value is 1 millihenry and C value is 0.01 into 10 to the power 6 because it is in microfarad. So this you will get 3 into 1.6 into 10 to the power 5 kilometer per second because the length of the line is in kilometer and L and C are given in per kilometer only. Okay. So this is what we get the value of V here. Now put the values here. 2 into pi is 3.14, F is 50, length of the line is 400 kilometer, the value of V is 3.16 into 10 to the power 5 and from here you will get the value of beta to be equals to 0.398. So that will be the value of beta. So this is how you will calculate the beta value. Now come again here and once you will put the beta value to be 0.39 here, 1 minus beta square by 2, that is what? That will come out to be 0.920 or 0.92. Okay. So we have calculated now the value of A. Now Vs has been given to us. What is Vs? Vs is 440 kV. The value of A is 0.92. So from here if you calculate this you will get 478.76 kV as the answer. So this is how you can approach for this question. I hope now you are getting the answer by the same approach, isn't it? You are getting the same answer by using the same approach. So through this problem, I have revised all your concept related to this particular topic, isn't it? Very good, very good. Okay. So this is the value of A, guys. For a long transmission line, if it is represented by its equivalent pi model, the value of A and D are equal and that is equals to 1 plus Yz by 2. Y and Z are given by these formulas. And since the line is not having any resistance value and inductance conductance value, the line is lossless line. The propagation constant is given by this. So phase constant, beta is basically the phase constant. So this will be equals to beta is equals to omega under root LC. Beta is also calculated by 2 pi FL by V. V is the velocity. We can calculate it by this manner. Beta we can calculate by after putting the values here. And once we got the beta, we can calculate the value of A and then we are able to calculate the value of VR here. So this is how we will solve this particular problem here. I hope all of you have understood how to approach for this problem, and while solving this problem we have revised all our concepts related to this particular topic as well. I hope this is very, very clear to you. Nayan, Asutosh, Neha, Nitin, are you people able to get this concept? Are you people able to solve this question? Did you get the fact how to solve this question? Under no load the line is operating. So this is a kind of Ferranti effect that we have. Okay. So this is how you can approach for this problem. Now, this is the end of this particular topic, compensation technique. Now the next topic that we have that I am going to discuss today is the load flow analysis. Okay. Please repeat the approach. Okay. See, what you have to understand here is we are given with the no load condition. Okay. We are given with the no load condition, that is IR is 0. So what are the ABCD parameters? If you write the equation in terms of ABCD parameter for a transmission line. Yes, Naru, after this question I will give a break. Okay. So this will be the ABCD parameters, equation of ABCD parameter. Now when you will put IR to be 0, you will get VR equals to Vs by A. Now Vs has been given to us. We need to find out the value of A. So from here we are getting that we have to calculate the value of A. Now what is A here? A is given by 1 plus Yz by 2. That is what we have learnt during the equivalent pi model, isn't it? So Y is the admittance of the line, which is G plus j omega C, and Z is the impedance, which is G R plus j omega L. Since the line is lossless, no resistance, no conductance is given, so what we can do, G and R we will put 0. So Yz will be what? Yz will be omega square Lc, isn't it? Or gamma, propagation constant is under root Yz, so which is equals to alpha plus j beta. So once you will put the values in R and G, you will put 0, you will get the value of beta here. Okay, so from here we just got the fact that we need to calculate beta and B, and after calculating beta and B we can calculate A, and finally we can calculate VR. So this is how we can solve this problem and we can approach for this problem. So as you people are asking me for a break, so I am giving you a break. So we will be right back after 5 minutes, and then we will discuss one more important topic, that is load flow analysis. So I have a very what we say excellent question in this chapter as well. So we will meet right after the break. So hello everyone, welcome back. So the next topic that we have that I'm going to discuss after the compensation topic is the load flow analysis. So in the load flow analysis, the important topics are classification of buses, bus admittance matrix, Jacobian matrix, and economic load dispatch. These are the topics from where you can expect a question in the upcoming GATE exam. So hi, very good evening Nikhil and very good evening Hers. Great to see you guys. So these are the very important topic, and guys, as I have told you earlier that from the load frequency control topic, you will definitely get a question. Similarly, from this particular topic, the bus admittance matrix or the topic Jacobian matrix, definitely you will get a question of 2 to 3 marks from these particular topics as well. Okay, so here I am starting with the very first problem. Just see this problem. What has been given in this question is the 4 bus system is given below, where all the values are marked in ohm. If suppose this line would have not been written, even then you can recognize whether all the values are in impedance values or in the admittance value. So if you see, the reactance is there and J.5 is written. So absolutely this is the impedance value. Similarly, if you see, everywhere it is J.2 or 0.5 is written, and we have reactor, inductor there. So of course this is the impedance value. Okay, if this would have been the admittance value, minus J would have been written there. So this is how you can recognize, but this has been mentioned here that all values are marked in ohm. So this is impedance values that we have. Now what we have to do, we have to find the value of this particular thing. What will be the magnitude of mod of y11 minus y14 plus y23 plus y34? That is what we have to calculate. So I think this is a kind of question that you people can solve, and I'm giving you only 2 minutes for this question. So let me check whether you are able to solve these kind of question or not. Okay, so you have 2 minutes to solve this question, guys. Take your time and give me the correct answer for this question. Nilmesh, Nayan, Nikhil, Hers, you can take your time and get me the correct answer. Give me the correct answer for this question. You can expect this kind of question in the upcoming GATE exam. Okay. Again, Nilmesh has solved it, and Nilmesh is saying C is the correct answer, and of course C is the correct answer. Very good, Nilmesh. One thing I must have to appreciate, that you are in a great touch of this subject. Keep this on. Okay, excellent. You have answered almost all the questions correctly. Very good. That is what is required to get a great rank in GATE. Okay, well done, Nilmesh. Keep up the spirit. So you are left with last 30 seconds. Harsh, Nikhil, Nayan, can you guys solve this question? Very good. Harsh is also getting the same answer, 7. Very good. Very good, Harsh. So last 5 seconds are left. And the time is up. So what we have to do, we have to find the values of these particular equation. And if you see in this equation, we require the value of y11, y14, y23 and y34. So except y11, all others are off diagonal element, isn't it? So how do you calculate the value of y11? So for calculating the value of y11, all the admittance connected to one bus number 1 will be added. Okay, since all these are in their impedance form, so we have to convert them into admittance form, and that will be 1 by J.2 plus 1 by J.5 plus 1 by J.5. So what do you get here? This will be minus J 5, this will be minus J2, this will be minus J2, and this will be minus J9. Now what will be the value of Y14? Since Y14 is the off diagonal element, Harsh is now saying the answer is 11. Let me check. Y14 is what? Y14 is the off diagonal element. So what we have to do? We have to first of all put a minus sign, isn't it? Before all off diagonal element, we will put minus sign here. Y14 means the value, what we have to do? We have to first of all check whether bus 1 and 4 are connected. Yes, they are connected, and they are connected with an impedance of J.5. So we have to convert this into the admittance. So 1 by J.5 will be there, and you will get J2. That will be the value of Y14. Now we need Y23 here. So what will be the value of Y23? That we will determine. First of all, we have to put a minus sign because it is an off diagonal element. Y23, so 2 and 3 are connected with an impedance of J.5. So this will be 1 by J.5. So this will come out to be J2 plus J2 that we will be having here. Now what will be the value of Y34? So it is again the off diagonal element, so we have to put a minus sign before. Y34 means 3 and 4, they are having a value of J.5 connected in between them. So again what we need to do is 1 by J.5. So you will get J2 here. So we have calculated all the terms. Now it is the time to put the values here. So once you will put the value, what is the value of Y11, guys? It is minus of J9 minus. What is the value of Y14? It is J2. Now what is the value of Y23? It is J2 again, and the value of Y34 is J2 again. So what do you get here? This is minus J11 and this is plus J4. So you will get minus of J7 inside the mod, or you will get 7. So 7 is the correct answer, and Nilmesh has answered it correctly. Very well done, Nilmesh. 7 is the correct answer. Initially Harsh has also answered C, but I don't know why he has deleted his answer. Harsh, your answer was absolutely correct. It is 7. Okay, so I hope rest all the people have now got how to solve this kind of question, isn't it? Isn't it a very good question, guys, where we have to calculate the values of certain elements of a Y bus, and then we are adding or subtracting few elements, isn't it? Is this a very good question, guys? What do you think about this question? So now let me move to the next question. Now this year I am expecting that one question involving a transformer between two buses will be there in the GATE exam. Okay, mind my words. This time, this year in 2023, you will definitely get a question which is involving from the Y bus topic, which is involving a transformer between two buses. Okay, I have few questions related to this topic as well, but let me first of all, let me check whether do you know, if there is a transformer between two buses, how to find out the Y bus matrix for that particular system. Okay, so this is the problem that we have. So we have two buses, V1 and V2, and the line admittance is Y. There is a transformer connected in between them which is having a ratio 1:A. Now we have to find out what will be the bus admittance metric for this particular system. So let me tell you how we will calculate. Now Nilmesh has answer for this again, and he is saying B. Yes, Nilmesh, B is the correct answer. If you know this, if you can remember this fact, you can solve the question that is about to come in the GATE 2023 exam from this topic. Be very sure. Asutosh is also saying the B is correct answer. So let me tell you, if you don't know how to solve these questions. So first of all, if this is the voltage V1, what will be the voltage here? It will be V1 dash, isn't it? Now if this is the current I1, and let me call this current to be I1 dash, and here let me call this current to be I2 dash. So first of all, what do we have here? We have V1 upon V1 dash, this is equals to 1 by A, or we have V1 dash, this is equals to AV1. Similarly, in terms of current, we can write that I upon I dash, that is equals to what? I upon I dash, that will be equals to A, isn't it? I upon I dash, I1 upon I1 dash, that will be equals to A, or what we can write I1 dash, this will be equals to A upon I1. Is that correct, guys? I1 upon I1 dash, this will be equals to A, or we will get I1 dash, this is equals to I1 upon A. I1 upon A. So we have here I1 upon A. So these two are the very important equations, equation 1 and 2. Other equation that we have, and let me we will discuss that later. Now see here, what we can write here, that V1 dash minus V2, this is equals to what, guys? V1 dash minus V2. What will be this? V1 dash minus V2. V1 dash minus V2, this will be what? This will be, or in other way, let me write about the current, not voltage, let me write about the current. What will be the current I1 dash here? Current I1 dash, you will find V1 dash minus V2 into Y, isn't it? Because I is what? V upon Z, or we can also write I is equals to V into Y. 1 by Z is what? It is Y. Now put the values here. What is I1 dash? I1 dash is basically I1 upon A. What is V1 dash here? V1 dash is AV1 minus V2 into Y. So from here you will get I1, this is equals to A square YV1 minus AYV2. This is equation number 3. Now one more thing, we can write that I2 is basically equals to minus of I1 dash here, isn't it? We can write this thing here. What is I1 dash? I1 dash is basically minus of I1 by A, and I1 you have already found out from equation 1. So what you can do, you can put that value here. This is A square Y V1 minus AY V2 here. Now what value of I2 you will get? You will get AY V1 minus Y V2. This is equation number 4. Now from equation 1 and from equation 3 and 4, if we write them in the matrix form, I1 and I2, these will be equal to what? In terms of V1 and V2, what values we are getting? So from the first equation we are getting A square Y and minus of AY. Then in the second equation we again have minus here. This will be minus here and this will be plus here because we have minus outside. So it will be minus of AY and it will be Y here. Okay. So this will be the Y bus matrix that we will be having in A square Y and Y. These will be the diagonal element, minus AY and minus AY. These will be the off diagonal element, isn't it? So this is how we will solve such a situation where we have a transformer connected between two buses. If there would have been no transformer, it's as easy as it can be, isn't it? But if suppose we have transformer connected between two buses, then how to tackle these problems? You can get that solution from here, guys. Okay. Now, which option is correct as per this equation? Option number B is correct. So both Neelmesh and Asutosh have answered this correctly. Very good. Very good, guys. Now, if you are able to know this particular concept, then I have a different problem for you. I have a different problem for you. Okay. Now, just read this problem. For the 3-bus system as shown in figure, the voltage ratio of regulating transformer is 0.5. So we have 1:A, this is equals to 0.5, or 1 by A, this is equals to 0.5, or the value of A that we have is 1 upon 0.5, or what I can say it is 2. Okay. Then the Y11 element of the Y bus matrix will be what? What will be the value of Y11? That is what we have to calculate here. Okay. So let me see. By using the previous concept, can you people solve this problem? So let me give you 2 minutes. Let me check. By using the previous concept, can you guys solve this problem? And let me write the Y bus matrix again, what we have obtained in the last case. It is what? It is A square Y, Y here, and here we have minus AY and minus AY. So you can use this concept whenever we have a transformer connected between two bus, the Y bus matrix of equivalent system will be this. You can use this concept in order to solve this question and tell me what will be the value of Y11, guys. You can use this concept to solve this question, okay? Now let me check whether you are able to utilize this concept or you have any problem in solving this question. But believe me, this year I am expecting a problem from Y bus topic involving transformer between two buses. That may come in your exam, okay? Now this transformer is connected between 1 and 2. It might be there between 1 and 3. It might be between there 2 and 3. Okay, so like this the problem can be changing, but the way of solving it will be the same. Again, Naru is getting an answer of 8. Well, I will say that you can check your answer once again, whether 8 is the correct answer. And let me know it from others as well. What answer you guys are getting? Minus J5. Very good, Hers. Minus J5 is the correct answer. Well done. Very good, Hers. And great to see you here. So the time is almost up. Last 2 seconds we have. Okay. So Naru and Hers has answered this, but Hers answer is absolutely correct. Let me check this. So guys, we have this particular situation, okay? Now, if suppose we have a transformer connected between two buses, in such a scenario, what we have obtained if suppose this is having a ratio of 1:a. In such a scenario, what Y bus matrix we have obtained? The Y bus matrix that we have obtained is A square Y minus AY minus AY and Y. This is what the Y bus matrix we have, isn't it? This is the Y bus matrix that we have. Now, tell me what is the Y11 element here? What is the Y11 element here? So Y11 element here is A square Y, isn't it? And what is the Y12 element here? Y12 element, if you see, that will be minus of minus AY, that is AY, isn't it? So if I want to calculate what is the shunt element of bus 1, the shunt element at bus 1, what will be that? So how do I calculate that? Y11 not, that will be Y11 minus Y12, because when you are calculating Y11, you must have added all the components connected to bus 1. So if you want to calculate what is the shunt element, you have to eliminate the off diagonal element from the diagonal element, and you will get the value of Y11 not. So we have A square Y here and we have AY here. So what do we get? We get A minus 1 Y. So that is the element which is connected here. So we will connect this element here having a value A minus 1 into Y. So this is what we have obtained. The element connected to bus number 1, shunt element we have obtained, isn't it? Isn't it? And let me not draw this here. Let me draw this separately. So you will get the concept very clearly, okay? Let me draw this separately, not here. Yes, let it be like that. Now, what will be the shunt element connected at bus 2? So for that we have the value of Y22, which is Y, and we have the value of Y12 we have already calculated, which is Y21 or Y12, which is AY. So what will be the shunt element? Y22 not connected to bus 2, that will be Y22 minus of Y21. So it will be Y minus AY, or we will get 1 minus A into Y, isn't it? 1 minus A into Y. So that will be the values of shunt element connected to these bus. Now if I draw this separately, this is my bus 1, this is my bus 1, bus 2. So I have bus number 1 here, I have bus number 2 here. that element is what? Y12 element, and it is having a value of what? It is having a value of Y12 element is what? This is coming out to be AY here, isn't it? Y12 element is AY here, and the shunt element that we have is, at bus 1 we have a shunt element equal to A minus 1 into Y, and at bus 2 we have a shunt element which is 1 minus A into Y, isn't it guys? This is what we have obtained here. Is that clear? Till now I don't think you people are having any doubt. So if we want to reduce this particular network, how we can reduce this? This will be replaced by an impedance admittance here, and that admittance value will be what? A into Y. What is A here? A is basically 2 and Y is minus J1. So this will be minus of J2. Now we can replace this with a shunt element here. And what will be the value of this shunt element? A minus 1 into Y. So that is 2 minus 1, that is 1, and Y is minus J ohm. So that will be what? Minus 2J Siemens, not ohm. And here we can replace this with a shunt element which is having a value A1 minus A into Y, or 1 minus A will be minus 1, Y value is minus J1, so we will get J of 1 here. Okay, so these will be the shunt element values, isn't it? As per the concept that we have utilized here, if you see this particular concept, we can reduce this network into this particular network, isn't it? Now what we have to calculate here? We have to calculate the value of Y11. So what will be the value of Y11? Can you tell me? The value of Y11 element will be, the value of Y11 element will be the sum of all the admittances connected to bus 1. Now if you see at bus 1, what do we have? At bus 1 we have this element and this element. So this element is having a value of minus J2, this element is having a value of minus J2, and this element is having a value of minus J1. So how much it will be? This will be minus of J5, isn't it? This will be minus of J5. So this is what we have to calculate, guys. Okay, so what will be the value of Y1 element? This will be minus of J5, isn't it? But since this is a NAT type of question, so you can write minus 5 or you can also write plus 5. Both answer will be treated as correct answer. Okay, but how to calculate? You have seen here Y11 value will be minus of J5. So both Hers and Naru both have done this question correctly and they have answered the correct answer. So I hope you people have got the concept of solving this question. Okay, now I have one more such question for you. So guys, I am not going to solve this question. Take a snapshot of this question, and this problem is a homework problem for you. This problem is a homework problem for you. So you can solve this question and you can type your answer later in the comment box. Okay, this is the same kind of question that we have. Here we have an transformer connected between bus 1 and 2. So here the Z is given to you. What is the Z value here? Z value is J.025. So from here you can calculate Y by doing 1 by Z, and 1 is to A, the ratio, this is given you, 1 is to A is given 0.8 is to 1. So from here you can calculate A, which is 1.25, I suppose. Okay, so the A value will change here. That is coming out to be what? That is coming out to be 1.25. So you can take a snapshot of this, you can solve this question, and you can put your answer in the comment box and I will reply there. Whoever is getting the correct answer, I will reply there. Okay, and let me tell you the answer as well. So what we have to calculate? Y22 element. So the Y22 element coming is minus of J 52.5 per unit. Okay, so you can calculate, you can solve this question and you can check whether you are getting the same answer or not. Okay, because this is a kind of repetition of question. So what I am getting a feel that this year there might be a question from the concept of Y bus which involves a transformer between two buses. Okay, so that is the purpose I have taken 3 problems. So 2 I have solved, 1 you can solve by your own. Okay, is that done, guys? So I am now moving towards the next question. Now see this question, and I am giving, again I will give you 1 minute only for this question. First read this question with me. The bus admittance matrix of a power system is given by, this bus admittance matrix is given to us. What will be the number of buses with shunt capacitance and shunt inductance? We have to comment how many buses have shunt inductance and how many buses have shunt capacitance, and in what number they have the capacitor and inductor connected with them. So this is what we have to do here, and I am giving you only 1 minute for this, because this does not require more than 1 minute. So let me check whether my students can answer this question or not. Simple logic, simple concepts you have to use here, guys. Okay, and let me check whether you can answer this question or not. Asutosh is saying option C and D. 2 buses with shunt inductance, 1 bus with shunt capacitance. C and D. And Asutosh, you are absolutely correct. C and D are the correct answer. Hers has also answered C and D. Very good, Hers. Okay. So how can we, in order to find the number of branches having shunt element, what is the concept involved in it? What you have to do, you have to just sum the rows, or you can do this with column as well. So if you are summing the row number 1, what will be the summation of this? You will get minus J25. So row number 1, after summation it is not giving 0. That means the bus number 1 is having the shunt element. Okay. Now whatever is the value, this is the value of shunt element connected to this one. So bus 1 is having a shunt element. Now we have formed the Y bus matrix. So everything written inside it is in admittance form. So what we need to do, we need to convert this into admittance impedance form. So what we need to do, we need to inverse it, and then you will get J upon 25. Now this is in impedance form. Okay, this is in impedance form. So guys, in impedance, if you are getting plus J, that means what is it? It is basically an inductor. Yes or no? It is basically an inductor. So this is how we have recognized the fact that bus number 1 is having a shunt inductor connected to it. Similarly, if you sum the row R2, the summation of row R2 will give you minus of J7. So again, it is not 0. That means bus number 2 is having a shunt element connected to it. Now this is in admittance form. So what you need to do, you need to inverse it, and then you will get J upon 7, that is the impedance, and again J is coming in the impedance form, and it is positive J. That means what it has? It is having inductance as well, isn't it? It is having inductance as well. So it is also an inductor. So 2 inductor we have found out. Now what we have to do, we have to sum the third row. So if you sum the third row, what you are getting? 18 minus 15, that will be J3. Now this is admittance. You have to inverse it in order to get the impedance. So it will be minus J by 3. So in the impedance, if you are getting a minus J, that means it is a capacitor. This is a very well known fact for you, isn't it? So guys, what we have obtained, that we have 2 inductors and 1 capacitor, means option C and D are correct, and both Asutosh and Hers have answered this question correctly. Well done. Well done Asutosh, well done Hers. Okay. So this is how we can solve these kind of question. Now let me move to the next question for you. Now this is a very conceptual question. Let me see whether you guys can answer this question or not. What it says is, in a load flow solution, if the voltage at bus I is Vi equals to 1.208 angle minus 70 degree per unit, and the voltage at bus J is Vj equals to 0.713 angle 12 degree per unit, which of the following statement is correct? P is flowing from I to J and Q is flowing from J to I. Answer option B says P and Q both flows from I to J. Option C says P flows from J to I, Q flows from I to J, and option D says P and Q both flows from J to I. Now let me see who can answer this question correctly. So I am giving you 2 minutes, okay? Think for it, guys. This is a very conceptual question that I have. If you are able to solve this question, you can do anything in the GATE exam. I am very sure that you are going to get a very good rank. So let me see who can solve this question. Hers is saying answer C. Very good, Hers. Very good, Hers. And C is exactly the correct answer. Very good, Hers. Naru is also saying C is correct answer. Very good. Well done, yeah. Well done. If you are able to solve this question with that much of speed, you are in great touch of this subject, okay? Asutosh is also saying C is the correct answer, so I don't think there is a need of this walk, okay? So guys, what concept is involved in it? If suppose we have a bus I and bus J here, and they are connected with each other with some impedance or admittance. Now bus I is having a voltage of 1.2 angle minus 70, and bus J is having a voltage of 0.71 angle 12 degree, okay? Then whatever is the power flowing here, PR and QR, what are those expression for those? So if suppose this is an let us suppose that J is only having an inductance, which is a normal case here, then what is the value of PR and QR? How do we calculate the value of PR and QR here? The value of PR is given by Vs into Vr, which is I and J here. Let me write I and J here. Vi Vj upon XL sine del 1 minus del 2, and the value of QR is what? QR is basically Vi Vj upon XL cos of del 1 minus del 2 minus Vr square by X, okay? Yes, very good. Yes, Naru, exactly the same concept is there. So guys, if you see del 1 minus del 2, if del 1 minus del 2 is positive, that means PR is positive, means PR is flowing from I to J. But in our case, what is the ratio of, what is del 1 minus del 2? So in our case, del 1 minus del 2 is what? Del 1 is having a value minus 17, del 2 is having a value minus 12. So it is exactly minus. So del 1 minus del 2 is negative. That means PR is negative. So PR is now flowing from this direction to this direction, opposite to the assumed direction, isn't it? Similarly, if we talk about QR, so if we talk about QR, we have cos here. So del 1 minus del 2, whether it is positive or negative, that actually does not matter. And let me take cos del 1 minus del 2 to be 1, okay? Let this cos del 1 minus del 2 by, for example, if I am choosing it to be 1, then what will be the value of QR? QR then will be equal to, let me write here J, not QR. So what will be this? This will be, we will take Vj common, and it will be Vi minus Vj divided by XL then, isn't it? So you see, we have Vi minus Vj. So if Vi is greater than Vj, then QR is positive. If Vi is less than Vj, QR is negative. So what is the case here? Vi is 1.2 here and Vj is 0.7. So we have Vi greater than Vj. That means QR is positive. So that means QR is flowing from I to J, isn't it? So we have QR flowing from I to J. So always remember the fact, without doing this analysis, you can remember active power always flows from higher angle to lower angle. active power always flows from higher angle to lower angle. But when it comes to the reactive power, it always flows from higher voltage to lower voltage. So when it comes to reactive power, you have to see about the voltages. When it comes to active power, you have to see about the angles. So active power will always flows from higher angle to the lower angle voltage, and reactive power will always flows from higher voltage to the lower voltage. Or you can do this analysis as well to understand the concept if you really don't know. Okay, so both Asutosh, Harsh and Naru has answered this question very correctly. Very well done. So let me move toward the next question right now. Now guys, we have this particular question for you. The reactance diagram of a system is shown in figure. All impedances marked in per unit. So these all are impedances here. The magnitude of sum of all diagonal elements of Y bus will be what? What we have to calculate? We have to calculate what will be Y11, Y22, Y33 and Y44. Their magnitude will be what? That is what we have to calculate. So let me give you 1 minute of time for solving this question, and I'm sure you can solve this question without even wasting 1 minute. So let me check who can solve this question. Last 25 seconds. Last 10 seconds we have. So Naru has answered that 35.6 will be the correct answer. Okay, let us check. So guys, if we are calculating Y11, so we have this bus number 1. So all the values are in the impedance form. So in order to convert them into admittance, we have to inverse them up. So bus 1 is having this element and this element connected to it. So what we will do, we have to inverse them. So it will be what? It will be 1 by J5. This will be 1 by J5 plus 1 by J.2 plus 1 by J.2, or else we will be having minus of J.2 minus of J.5 minus of J5 and minus of J5. So how much we will get here? This will be minus 10.2 per unit, isn't it? This will be minus 10.2 per unit. Yes, I am getting different answers. Okay, although this is a very simple case, but yet I am getting very different answer, and that is why I have chosen this question. Okay, now when it comes to bus number 2, we have this element and this element connected. So almost same values we have as we have in case of Y11. So again it will be minus J.10.2 per unit. Okay, what will be the value of Y33? So when it comes to Y33, see guys, this is bus number 3, and at bus number 3 we have 4 elements connected to it. So what will be Y33? It will be 1 by J5 plus 1 by J.2 plus 1 by J.2 plus 1 by J.2. So we will get additional 5 here. So it will be minus of J 15.2 per unit here. That will be the value of Y33. Now what will be the value of Y44? So when it comes to Y4, we have 3 elements connected to it, and that are 1 by J.2 plus 1 by J.2 plus 1 by J.2. So that will be what? That will be minus of J15 per unit. Now we have to add them up. So if you add them up, what will be the summation? 15 and 15, that will be 13.2. 13.2 and 20.2, that will be 15.6. So what is the result of, what will be the result of y11 plus y22 plus y33 plus y44? You have to add them up and you will be getting minus j 50.6, or what I can say is 50.6 per unit. So that will be the correct answer. Now who has answered this correctly? Hers and Asutosh and Naru. Each one of you have answered it correctly, but earlier you have given different answers. So although this seems to be a very simple problem, but yet you people are making mistakes. Okay, so just don't commit this mistake, guys, unless you will lose very easy, very silly 2 marks, isn't it, in a very silly question. Okay, so that is the purpose of choosing this question. Since you people are making mistake right here, you can also commit a mistake in the GATE exams. Okay, so whatever, in whatever place you have done it wrong, just make a reminder of that note. Okay, now let me move to the next problem. Now this is a very good problem that I have. Just read this problem with me and let me see who can answer this question. The fuel cost for a power plant with 3 generators are, so first generator is having this fuel cost, second is this having this fuel cost, and third generator is having a fuel cost of 60 rupees per megawatt hour, where P1 is the real power in megawatt. Assume all 3 generating units are working simultaneously. They are operating in parallel, they are working simultaneously all time. Minimum and maximum loads on each unit are 100 megawatt and 500 megawatt. So one generator can take a minimum load of 100 and maximum load of 500 megawatt. Okay, respectively, a plant is operating on economic load dispatch. So economic load dispatch is there, plant is operating economically to supply the total power demand of 900 megawatt. Guys, total power demand that the generators are supplying simultaneously is how much? 900 megawatt. The power generated by each unit will be what? That is what you have to calculate. Okay, so when it comes to economic load dispatch, I know that there are some conditions, 2 such conditions, considering losses and without considering losses, 2 popular conditions, and you immediately apply those conditions. But let me check whether you are able to solve this question or not. This is a very good question that I have. Okay, if this would have been a simple case, you can solve that very easily. Okay, but if this kind of reasoning question will be there, let me check whether you can reach up to this question or not. That is the purpose of choosing this question, to make you aware of these kind of scenario and these kind of situations. Okay, so let me just check whether my students are able to solve this question or not. So take your time and tell me what is going to be the answer for this case. So last 30 seconds are there. Asutosh is saying option D is correct. 155, 500 and 245. So time is up and only Asutosh has given an answer. He said that option D is correct. So let me check. So how to approach for this kind of question, guys? See, the minimum load that a generator can take, a unit can take is 100, and the maximum can be 500 megawatt. Okay. So how the loading of the generators will be done? Economic load dispatch means we will not load any of the generator, we will not overload any of the generator, and we will look into their operating cost. If suppose one generator is having a low operating cost, we will load that generator first. Okay, we will not overload a generator which is already having a higher operating cost. Just remember this fact and you will be able to solve this question. So let me consider, let P1 is minimum. P1 is sharing minimum, that is P1 is equals to 100 megawatt. Okay. So if P1 is sharing 100 megawatt, what will be its operating cost? So its operating cost is 20 plus 0.5 P1. 20 plus 0.5 P1, that is 20 plus 0.5 P1 is 100. So how much we are getting here? We are getting, I think, 70. Okay. So operating cost for plant 1, if we are considering that it is sharing the minimum, is 70. Now let P2 is sharing the minimum. Let us suppose P2 is minimum, that is P2 is sharing the minimum load of 100 megawatt. So if P2 is sharing the minimum load of 100 megawatt, what is its operating cost? 50 plus 0.6 P2. 50 plus 0.6 P2 we have. So 50 plus 0.6 into 100, what do we get? We will get 110. Okay guys, and what is FC3? FC3 is given to us, which is 60. Okay, and we have considered that, what we have considered here, if P1 is sharing the minimum load, if P2 is sharing the minimum load, what is their operating cost? 70 and 110. Still it is higher than the FC3, isn't it? So even though if P1 and P2 are sharing the minimum load, yet their operating cost is higher than the third one. That means the third one is having the lowest operating cost among the all threes, even if P1 and P2 are sharing the lowest of the load. So what it interprets is that we can load the third unit up to the maximum. So that tells that what it tells you, that FC1 and FC2, they are greater than FC3, means this generator, the third generator, can be overloaded. So it can be overloaded. So what we interpret from this, that P to P3 can share the maximum load, guys. P3 can share the maximum load, because when we have loaded P1 and P2 to their minimum loading, even then their operating cost is greater than the last one. So that means last one can be uploaded more. Last one can be loaded up to the more rating, isn't it? So we can load it up till the maximum limit. We can load it up to 500 megawatt, isn't it, guys? What does it mean? Isn't it? Are you getting, guys, this particular concept you are getting? Even if P1 and P2 are loaded to their minimum limit, yet their operating cost is minimum. That means minimum to what? Minimum than the third one. That means we can load the third generator up to the maximum limit that we have, isn't it? Hello Vijay. So we can load the third generator up to the maximum limit. So P3 can be as high as 500 megawatt. Now see, what do we have? We have P1 plus P2 plus P3, this is equals to 900 megawatt. So what do we get from here? P1 and P2, this will be 900 minus P3, 900 minus P3, that is 900 minus 500, it will be 400. So let me call this equation number 1. Okay. Now P3 alone is taking 500 megawatt. Now the rest of the load of 400 megawatt, we have to economically dispatch this load among P1 and P2. So there is a condition of economic load dispatch between P1 and P2. So if this is the condition between them, what we can say here, for economic load dispatch for ED problems, what we can say here, for ED problems, FC1 must be equals to FC2. So what do we have? FC1 FC1 is basically equals to 20 plus 0.5 P1, and FC2 we have 50 plus 0.6 P2. So this is equation number 2, this is equation number 1. So after equation 1 and 2, from equation 1 and 2 guys, from equation 1 and 2, you will get the value of P1 and the value of P2. So the P1 value will be 245 megawatt and the P2 value will be 155 megawatt, and P3 we are already having. What is the value of P3 here? 500 megawatt. So what is going to be the answer? After solving equation 1 and 2, you are getting P1 to be 245 megawatt, you are getting P2 to be 155 megawatt, and the P3 will be 500 megawatt. So this is how we have decoded the hidden fact of this problem. I hope you people have understood the solution. So which option is correct? 245, 155 and 500. Option A is correct. Option A is correct. So Asutosh, did you get the fact why option D is not correct? Tell me guys, are you able to understand this problem? See, we have applied the economic load dispatch condition later on, but initially we have decoded which generator will be loaded to the maximum limit. Isn't it? Very good. Very good, yeah. Very good, okay. So if this would have been a simple problem, you will easily crack it. But if the problem has some hidden fact like this, you must be aware of that, okay. So if you are able to remember this fact, I am very sure whatever is the problem from this topic, economic load dispatch, you will definitely get 2 marks from it, okay. Now let me move to the next problem. Now this is the next problem that I have, and it says in a system consisting of 2 generating plants, the incremental cost in rupees per megawatt hour with P1 and P2 in megawatts are DC1 by dP1 is this much, and the second unit is having the incremental cost of this much. The system is operating on economic dispatch, okay. This condition is given to us with P1 and P2 values are also given, and dPL upon dP2 is also given to us. What will be the penalty factor for plant 1? That is what we have to calculate, okay. So let me give you only 1 minute, or 1 minute is sufficient to solve this problem, not more than that. So let me check whether you can solve this problem within a minute or it requires more time for you. Economic load dispatch condition you have to apply. Economic load dispatch condition without considering losses is what? DC1 by dP1, this is equals to DC2 by dP2. With considering loss is what? L1 DC1 by dP1, this is equals to L2 DC2 by dP2. So that is what you have to remember. So this question belongs to only the economic load condition considering the losses. But let me see whether you can solve this. Very good, Hers. Hers has already solved this and his answer is 1.25, and this is a wrong answer, Hers. This is a wrong answer. Check your answer twice if you are solving a question, okay. This might happen that you have used the correct formula, everything you have done correctly, but you may have done the calculation wrong. So is there anybody who is getting any answer? So guys, economic load dispatch considering losses. What is the condition for economic load dispatch? Economic load dispatch considering losses, okay, with losses. What is that condition you have? That condition is basically L1 DC1 by dP1, this is equals to L2 DC2 by dP2, isn't it? This is the condition that you have, yes or no? Now in this condition we have to, what is L1 and L2? L1 and L2 are basically the penalty factor. So penalty factor for plant 1 is what we have to calculate. We have to calculate what will be the value of L1. Do we have the value of L2? Of course we have. The penalty factor is calculated by 1 minus dPL by dP1, and we are given with that value. What is dPL by dP2? Penalty factor for 2, so it will be 2 here. So what is dPL by dTp2? It is 0.2. So L2 will be 1.25. So this is L2 what you have calculated as, not L1. Now come here and put the values. L1 is what we have to calculate. dC1 by dP1 is given to us 0.15 into P1 and P2 both are 100. So we can put the value of P1 100 plus 150 here. And what is L2? It is 1.25. What will be dC2 by dP2? It is 0.25. P2 value is again 100 plus 175. So you can see the only unknown thing here in this equation is L1. So once you will solve this equation, you will get the value of L1 to be 1.51. Are you getting the same answer? Very good. Asutosh has got the same answer, 1.51. Well done, Asutosh. So Hers, this is L1 that you have to calculate, not L2. You have immediately calculated L2, but it is L1 which has been asked here. So you can see why I am taking these questions here. The purpose of taking these questions to remove your doubt from your mind, to be very concept clear, okay? And I am sure that these questions are really solving this purpose, okay? So that is the purpose of the GATE Score Booster series, and I'm thinking the GATE Score Booster series is really serving its purpose out, isn't it, guys? It's better to make mistake here, not in the GATE exam, isn't it? You can make n number of mistakes here, but not in the GATE exam. Okay, so whatever you learn from here, that will be very helpful for you, and you will not make mistake in the GATE exam, and you will score full marks there, isn't it? So now it's time for the next problem. Now we have this particular question from ED problem. See here, what has been asked here is a power system has two generating plants and the power is dispatched economically with P1 equals 150 megawatt and P1 equals 150 megawatt and P2 equals 275 megawatt, and the loss coefficients are also given to you. In order to raise the total load on the system by 1 megawatt will cost an additional rupees 180 per hour. Okay. The penalty factor for plant 1 and additional cost per hour to increase the output of plant 1 by 1 megawatt will be what? That is what we have to calculate. So let me tell you what you have to calculate and what has been given. If you are increasing 1 megawatt, it is costing additional rupees 180 per hour. So this is lambda which is given to you. Lambda is 180 rupees per megawatt hour. So lambda has been given to you. Now you have to calculate what will be the value of penalty factor for plant 1 and additional power, additional cost to increase the output of plant 1 by 1 megawatt means you have to calculate what will be the value of dC1 by dP1, guys. These two things you have to calculate. I think I have given you enough amount of hint. Now my students can solve this question. So you have 2 minutes with you, guys. I'm sure that you people can solve this problem. I'm very confident that my students can solve this problem very easily, guys. With this number of hints, you can solve this problem. And with these 3 problems, I'm very sure there cannot be a GATE question which you people cannot solve. Okay? So 1 minute is remaining, guys. I hope you people can solve this problem very easily. Whatever questions I have chosen here, just solve these questions as many times as you can. And guys, I'm very sure you are going to rock in this GATE 2023 exam. Okay. Haven't done ED, sir. So if you haven't done ED, I think even then you are able to understand these concepts, because I am raising these concepts from very depth. Isn't it needed, Naru? If you haven't covered this topic in the class, even then you are able to go through this topic, isn't it? This is as simple as that. Whatever is required to solve these questions, I am covering all those topics from the very depth. So even if you are covering this topic for the first time, even then you are able to solve this question, isn't it? Is it like that? So just see this problem. What has been given to us in this problem? We have to find out the penalty factor for plant 1. Okay. So the penalty factor for plant 1, penalty factor for plant 1, it is L1. Okay. And it is given by 1 minus Deber PL upon Deber P1. Okay. Now, what is the loss equation? The loss equation is given by B11 into P1 square plus 2B12 into P1 P2 plus B22 P2 square. So, this is the loss equation that we have, isn't it? Penalty factor Asutosh has calculated and it is coming 1.42. Okay, let me check. Now guys, if we will do Deber PL upon Deber P1 here, what do you get? You will get 2B11 P1 plus 2B12 P1 here, isn't it? P2 here. Yes or no? And that will be equal to 0. Now put the values here. What is the value of B11 here? What is the value of B11? 0.10 into 10 to the power minus 2. 0.10 into 10 to the power minus 2. What is the value of P1 that we have? P1 is 150 megawatt. Okay, no need to write unit because it is in per megawatt and it is in megawatt. Yes, sir, I am understanding the questions but cannot attend the new questions. No problem. No problem. That is the purpose of this series, na? So this series is already helping, already serving its purpose, guys. So no need to worry about that. Okay. If you haven't covered any concept, you are covering it right now. Now 2 into, what is the value of B12? It is minus 0.01 into 10 to the power minus 2. I think Astos, you have missed this minus and that is why you are getting a different answer. P2 is 275. So now once you will solve it, what will be the value of Deber PL by Deber P1? It will be 0.245. It will be 0.245. So we have calculated this value. Now what will be the penalty factor? That we can do by 1 by Deber PL upon Deber P1. So just put the values here and you will get the answer. 1 upon 1 minus 0.245 and it will give you 1.32. That will be the correct answer. So Asutosh, are you getting the same answer? Check whether where you have mistaken. So this is how we will calculate the penalty factor. So Naru, are you getting how do we calculate the penalty factor? Whether this concept is clear right now? If you haven't covered this earlier before, you can get this concept, isn't it? So now what we have to do, we have to find out what will be the value of dC1 by dP1. Hello Ravi. We have to find out the value of dC1 upon dP1. So how do we find out the value of dC1 by dP1? So you know L1 dC1 by dP1, this is L2 dC2 by dP2, this is L3 dC3 by dP3. Ultimately this is equals to what? Ultimately this is equals to lambda, isn't it? So from here what we have to find out? We have to find out the value of dC1 by dP1. So that will be lambda upon L1. Lambda is 180 and L1 you have calculated is 1.32. 1.32. So from here you will get the value of dC1 by dP1 and that will be 136.36 rupees per megawatt hour. So do we have these values in the option? 1.42, 1.32 and 136. So this is option number A and option number D which are correct. I think Ravi has answered it correctly, but I don't know why he has deleted his answer. Yes, Ravi, option A and D are correct here. Okay, very well done. Very well done, guys. Asutosh is saying, yes, sir, got it where I have done mistake. Very good, Asutosh. So, Naru, are you getting how to solve these questions? Whatever concept required to solve economic load dispatch problem, we have discussed all here. So, just see these videos once again and you will get how to solve these questions. Okay. Now, let me move towards the next problem. This problem is from the Jacobian matrix concept. Okay. So, see what it says. A power system has 20 generators G1 to G20, out of which G8 is the largest. Okay, G8 is the largest. Mind this word, G8 is the largest. Hence chosen as reference bus. So this is what? This is reference bus or slack bus. So we have one reference bus or slack bus here, isn't it? Apart from that, G3, G1 and G3, G7 and G11 are operating at their maximum reactive power limit, guys. Their Q is fixed. So if their Q is fixed, they will be what type of buses? PV buses or PQ buses? Tell me about G3, G7 and G11. What we can understand is G8 is a slack bus. So we have one slack bus here. Now about G3, G7 and G11, it is written that they are operating at their maximum reactive power limit, means their Q is fixed. So if their Q is fixed, guys, they are PQ buses. Absolutely correct, Harsh and Asutosh. Very well done. So these are what? These are the PQ buses. Okay. If total number of buses in the system are 20, then what will be the size of Jacobian matrix during Newton-Raphson road flow analysis? That is what we have to calculate. So guys, the size of Jacobian matrix, how do we calculate it? Size of Jacobian matrix. The size of Jacobian matrix is J, which is equals to 2n minus m minus 2 into 2n minus m minus 2. Where what is n? N is basically total number of buses. Total number of buses here. What is m? M is basically total number of PV buses. Total number of PV buses. Okay. Now PV buses includes voltage controlled bus. They includes voltage controlled bus plus reactive power support buses. Okay, reactive power support buses. Sometimes this split data is given, so you have to choose it from there. Okay, sometimes this split data is given, so you have to choose it from here. Now Sachin has answered correctly. 22. Everybody has answered correctly. Only I am left, I think. Only I am left to calculate the answer. Rest all the people know this concept. So if you know this concept, this is the best thing that you have, guys, because this year you are going to get a 1 mark question like that in the upcoming GATE exam. Okay, so that is very good for you. So guys, can you tell me how many PV buses we have? How many PV buses will be there? See, we have total 20 buses. Out of these 20 buses, 3 buses are PQ buses, 1 bus is slack bus. So 4 we have to remove. So how much will be left? 20 minus 4, that is 16, isn't it? So what will be the size of Jacobian matrix? This will be 2 into total number of buses are 20 here minus the m value, that is PV buses is m here minus 2. So how much we will get? 40 minus 18, that is 22 we will get, isn't it? We may also use one formula. The size of Jacobian matrix is 2PQ plus PV. This formula will also help you in solving these questions, okay? But sometimes it's better to write or it's better to decode this formula in this particular manner, because sometimes the PV buses are not directly given to you. These are given in this splitted manner, where you will be given the voltage control bus, where you will be given about the support buses. So from there you have to decode this thing. So it's better, it's a better practice to know about these two formulas. So I think everybody is getting the same answer here, which is 22. So this is how we will solve this question. I hope everybody has got the same answer. Yes, very good. So this is how we will solve this question. So this is all about the load flow chapter, guys. So we have solved some tremendous question from this topic and the earlier topic as well, the compensation topic and this load flow topics. We have solved tremendous question. I hope you people have liked those questions, and I'm very sure these concepts or these questions will be repeated in this upcoming year, in this upcoming GATE exam. Okay, so practice these question or these concept as many times as you can, and you will be the person who will be the most benefited after watching these videos or this after joining this session. Now moving towards the next topic, insulator, cables and distributor. So here we have three important topics: insulators, cables and distribution. Now out of these three topics, insulator and cable are the topics from which we are getting regular questions. Okay, but sometimes distribution also have given question in the exam. So let me go to the first question first of all. Now let me read this question for you. A string of 7 suspension insulator is to be fitted with guarding rings. If the pin to earth capacitance are equal to C, then the value of line to pin capacitance C3 will be what? That will give you the uniform voltage. So we are using a guard ring here, guys. We are using a guard ring here. So capacitance to pth metal link, we have a formula here, capacitance to pth metal link. That formula you have to remember. This is equals to Cp equals to m Cm upon n minus P. Okay, where what is P? P is the link number. What is P here? P is the basically metal link number. Okay, P is basically the metal link number here. Metal link number. What is Cm? Cm is the pin to earth capacitance. Pin to earth capacitance. And what is N? N is the total number of, N is what? N is the total number of discs that we have. Okay, total number of discs that we have. So in our case, and while counting this capacitance of pth metal link, always remember the fact that we have to go from this way. Okay, not from this way. We have to come down from upper to lower unit, not from lower to upper unit. Okay, so we have to find C3 here. So if we have to find C3 here, so for C3 the P value here will be 3, N value that we have is 7, and Cm is given to us, which is C here. So what will be the answer here? M value. This is not M, this is P here. Okay guys, PCP upon N minus P. This is what we have to write here. So what do we have here? P is what? P is basically 3, Cm is C here, N minus P, that is 7 minus 3. So what we will get? We will get 3 by 4C. Do we have any option? Yes, of course we have option C. Option C is the correct option here. So this is how we will solve this question. I hope you have understood this, isn't it? This is a very, very important formula. You may be asked to calculate the ratio of C6, C5, C4, or you may be asked to calculate anything else apart from this C3. So this is how you can solve this particular question. Okay, I hope this is very, very clear to you. So let me move towards the next question. Now see, we have this particular question in which it has been asked that a 3-phase transmission line is being supported by 3 insulator discs. The voltage across the lowest insulator disc is 13.1 kV and that across the next unit is 11 kV. The voltage between the lines will be what? That is what we have to calculate. So we have 3 insulator disc here, isn't it? So if this is my tower, so if this is the tower that we have, so we have 3 insulator disc here. Like this, if we are having 3 insulator discs, and this is the conductor that we have. If this is the self capacitance, then this is the earth pin to earth capacitance, which is denoted by Kc. Now this voltage is V1, this voltage is V2, and we have this voltage which is V3. Now we have been given that the lowest insulator unit is having the voltage of 13.1 kV, and across the next unit is 11 kV. So V3 and V2 are given to us. What we have to calculate, first of all we have to calculate the V value, which is V1 plus V2 plus V3, and this voltage will be in phase value. We have to convert this into line. So how can we solve this problem, guys? So you know that V2 voltage is basically V1 1 plus K. So from here we can get the value of V1, which will be V2 upon 1 plus K. What is the value of V2? It is 11 upon 1 plus K. Then we can have the value of V3, which is K square plus 3K plus 1 into V1, or we can have the value of V1, which is V3 upon K square plus 3K plus 1. V3 upon K square plus 3K plus 1. So what is the value of V3? We have the value of V3, which is 13.1 divided by K square plus 3K plus 1. So if you see, this is the equation number 2 and this is the equation number 1. Equation number 1 and 2 both have the value of V1, and only unknown thing is K. So from equation 1 and 3, from 1 and 2, sorry, we can solve it for the value of K, and the value of K will be 0.1 here. So once you get the value of K, then you can calculate the value of V1, which is V2 upon 1 plus K, that is 1.1 plus 0.1. V2 is 11 upon 1.1, so that will be 10 kV. So now we can get the value of V. We can get the value of V, which is V1 plus V2 plus V3. And how much that will be? V1 is 10. This is 10 plus 11 plus 13.1. So how much it is going to be? I think this is going to be 34.1 kV. So that will be the voltage that we have. This is the total voltage that we have, V. But guys, this voltage is in phase form. But we have to calculate what? We have to calculate the voltage between the lines. So voltage between the lines, what will be the voltage between the lines? So for voltage between the lines, what we need to do? We need to multiply this by √3, and that will be the answer. And this is coming out to be 59 kV. So 59 kV is the correct answer. So do not forget to convert the total voltage into line values, unless that will not be a complete answer. Okay, very good. So Ravi is getting the same answer. Very good, Ravi. So this is how we will solve this problem. All you need to know is to remember these equations. If you can remember these equations, you can solve this problem. Instead of this equation, you may be asked to calculate the string efficiency at one, and that is equals to the total voltage upon n into the voltage of greatest voltage. So that will be V upon n into V3. So in that manner you can calculate the string efficiency as well. So if this would have not been a question, we would have been asked about the string efficiency. So this is how you can solve these questions, guys. Okay, now we have one more question, and that I will solve in tomorrow's session. Okay, so this is the end of this particular session right now. But let me tell you about the IMS programs at IMS that we have. So in IMS we have basically 4 programs: the classroom program, hybrid classroom program, exclusively live online program, and self-learning programs. Now what all these are having, let me just tell you. We are offering the GATE courses across these 6 streams: the mechanical engineering, civil engineering, electronics and communication, and electrical engineering, instrumentation engineering, and computer science and information technology engineering. Okay, thank you so much, sir. Very good, Ravi. Very good, very good. So just stay for 2 minutes, guys. I have a very useful information for you. that I'm going to reveal just right now after this. So just be there for 2 minutes. Okay, what are the programs feature that we have? So if you join in our live classroom program, we are offering 750 hours of live classroom teaching to you. 20 to 30 theory books we will offer you. 4,000 plus practice questions we will offer you through the exercise book. You made our work very easy. Very good, Ravi. And the GQB that you will get, and the doubt solving support you will also get from us. Okay, learned a lot in this session. Very good. Just stay for 2 minutes, guys. I have a very useful information for you. Apart from that, we have my plan strategic session, 130 plus test series that we offer, and we have the GATE score booster series that you are just have joined, and post GATE interview guidance we are also providing. So we believe in LPT methodology, learn, practice and test. So first we will make you learn the concepts and the things required. Then we are offering you 4,000 plus questions to practice more and more, and then we are offering you the 130 plus tests so that you can practice as well. So this is the feature that our test series is having. So we are almost offering you 84 number of chapter tests, 12 subject tests, and 12 advanced level and basic level subject tests, 8 multi subject tests we are offering you, and 12 full length tests we are offering you. So guys, you have almost gone through our GSB series, and you have seen the kind of questions we are discussing here. The same kind of experience or even better experience you will have if you will join our test series and you will go through all the questions. Okay, so that is going to help you a lot, believe me. Okay, about study material, so what we are offering you in mechanical engineering, we are offering almost 24 theory and exercise books. Civil engineering, we have 30 exercise and theory book. For EC, we have 22 books. For electrical, we have 24 books. And for IN, we have 26 books. And for CS also, we have 26 theory and exercise book. Now, this is the look of our student portal that we have. In this student portal, we have a dedicated doubt solving portal where you can post your doubts regularly, and these will be solved within 24 hours. Okay, this is the best feature that we have, guys. After that, we have one-to-one mentoring and one-to-many mentoring session. So suppose you are studying, we have planned that I will prepare for GATE exam. Now you will get n number of doubts. Now who will resolve your doubt? So for that, we have this my plan session where you can interact with us in one-to-one manner or in one-to-many manner, where you can where we will resolve all your doubts or queries related to the preparation. So this is the best what we say, the unique feature of us that we have. Now if you want to test us, you can just go our website imsindia.com and just go this GATE section, and you can go through the zero fee program that we are offering. So without even joining us, you can just check us. There we are offering 100 plus hours of concept video, 12 chapter tests, 6 subject tests, and 6 past GATE papers free of cost. So before actually you want to join us, you can check us what quality contents we are giving you. You can just check and then you can make your mind to join us. So if you have really made your mind to join us, we have an announcement for you. Our new batches are starting. So from Tuesday, we are starting signal and system for EC electrical IN, engineering mechanics for mechanical and CV, mechanical and civil, and TOC for CS in online manner. Okay, from 3rd of January, that is Tuesday. From 7th of January, we are starting networks, FN and hydraulics for mechanical and civil, and operating system for CS in online manner. Okay, so if you really want to join us, guys, do not waste your time, join us. Okay, you can make a call or WhatsApp on these number and you can join there. If you want to join us in offline manner, so we are starting a new batch from Sunday, January 8. For EC electrical IN, digital will be running there. For mechanical and civil, SOM will be running there, and for CS also digital is running there. So this is our office address. You can join us in online manner as well. Apart from that, we have GATE hybrid classroom program where 2/3 content will be given to you in online manner and 1/3 content will be given in offline. 2/3 will be given in offline manner and 1/3 will be given in online manner. So these are the details. From Tuesday, that is January 3rd and January 8th, new batches are starting. You can see the details and you can join us in GATE hybrid classroom program as well. So this is the end of today's session. So Ravi, thank you so much. Thank you so much for the class, sir. You made our work very easy. Learned a lot in this session. Excellent session, sir. Nayan is also saying thank you. Very good. Very good. So guys, if you have enjoyed today's session, you are going to enjoy a lot in tomorrow's session as well, because tomorrow I am going to discuss fault analysis, power system stability, two such concepts in which every student struggle. So if you don't want to really struggle in these concepts, these two concepts, do join the session on tomorrow, schedule on the same time from 6 to 9 p.m. and I will give you a great experience there as well that you have enjoyed in today's session. So I will be waiting for you in tomorrow's session, and thanks for being such a patient audience and answering the questions very well. Okay, so be ready for tomorrow's session. Tomorrow I will be waiting for you from 6 to 9 p.m. where I will discuss power system stability, fault analysis, power system protection, such important concepts. Okay, so I will be waiting for you tomorrow as well from 6 to 9 p.m. Be there. Thank you. Thanks for watching this session, guys.